All right. Okay, if you're interested in the matrix calculator, you can go through this with me. You might want to scoot forward a little bit, but that's up to you. Okay, let's look at an example. Okay, there's our example, right? So then if we want to plug that into the matrix calculator, where's the matrix calculator? It's right there. Okay, here we go. So the matrix calculator now, here's our 4x4 system. Remember that when you want to use a matrix to solve a linear system, all of the equations have to be in standard form. There's no other option. We have to have in this case, we have to have the W term first, then the X's, then the Y's, then the Z's equals a number, right? Has to be. So when you're doing, for example, the apple problem, right? The apple problem, X is like the number of one kind of apple, Y is the number of another kind of apple, Z is the number of the other kind of apple. When you set up that third equation, you have to write it in standard form before you can solve the system, right? And then you'll have the calculator for the application problem, okay? All right, so we're going to create a 4x4 matrix for the coefficient matrix. Matrix A, we'll call it. Okay, what are my coefficients going to be here? So I got 4, 5, -5, -1 for the first row. Then I get 1, 2, -2, 5, and then I get -3, -3, 1, -3, and then I get 4, 2, -5, 2. Correct? Okay, hit enter. So there's A. Need a new matrix now. That's my coefficient matrix. Now I need a constant matrix, right? So that's gonna be matrix B. What's the size? How many rows? How many columns? So four rows, 1 column, right? I want this to be a column matrix, so it's going to be a vertical matrix like that. Okay, and then I'm just going to put my entries are 53, 29, -34, and 50. Okay, and so I've defined matrix A and matrix B. Now all I have to do, if I want to get the answer right, it's always just going to be the inverse of the coefficient matrix times the constant matrix. There are my solutions.
Wait, so it's A times B?
It's A inverse
Oh,
times B.
okay.
So there's the inverse button right there. You have to hit A first, and then you hit the inverse button.
And it's just 1 row by 4 columns? Or is it 4 rows?
It's going to be 4 rows, because there's 4 small rows by 1 column, right? The rows are the horizontal,
Yeah.
and columns are vertical, right? Say that again? What do those numbers mean? So where did those numbers come from? They're the coefficients of the variables written in order. Right? So that's what A is. 4, like the first row is 4. Okay, so then let's do that step again, right? So to get that step, I defined matrix A as the coefficient matrix, matrix B as the constant matrix. When I push that button right there, that's pulling up matrix A, right? So we get matrix A. Look what it does. There's matrix A. But now I'm gonna, right next to that, I'm gonna hit the inverse button, and it inverts the matrix times, and I'm gonna push that button right there to multiply it by matrix B, and then look what it does. Okay, so what are those? Right. Okay, so now let's take a picture of that. Come on. How come I can't make that any bigger? That's too bad. Okay, so there's matrix A. Let me take some pictures and I'll put them on the notes.
Are you talking to me?
Okay, so there's matrix A and matrix B, right? And then we'll just roll down, and then I'll take a picture of this at the bottom, maybe. There we go. Maybe. Oh, this thing's, it's in beta. It's not working real. Oh, no, don't tell me I messed it up.
You did.
Oh, please don't do that.
I think your heart just got broken.
Oh, my goodness.
Aw.
Okay, this thing's really touchy. I don't know what to do about that. I guess I gotta redo the whole dang thing. Is that right? Okay, so now finally, an answer to question in the back. So what does that mean? So what this is telling us right here, I mean, just in case you didn't see this, what that's telling us is W equals 5, X equals 3, Y equals -4, and Z equals 2.
Okay, that's what.
Okay, yeah, that was your question, right? Yeah.
It works.
Okay.